Week 17, lesson 7. Okay, so this particular lesson is talking about more derivative rules. Now, the good news is the top two blue boxes you have pretty much done already. The first one, the top one, is just saying that if there's a constant out in front, you don't have to take the derivative of the constant. You're literally just taking the derivative of the function and multiplying it by the constant. And then this is saying that the derivative of the sum is equal to the sum of the derivatives, and the difference of the derivative of the difference is equal to the difference of the derivatives. All right, now what you may be noticing that is different is the notation. There's some different notation right here. Okay, this is just saying that you're taking the derivative of the function with respect to x. That's just what that notation means. You're doing the same thing, just it looks different. All right, and then down below here, the derivative of sine is cosine, but the derivative of cosine is the negative sign. All right, so I have a bunch of examples to do here. Hopefully it will make some sense. Here we go. So for this first example, I am going to rewrite this function as 2x to the negative 1. That way, when I go to take the derivative, I can take the exponent, multiply by the number that's out in front, rewrite my x, and reduce that exponent by 1. Now, all I have to do is clean this up. So f prime of x is going to equal negative 2 over x squared, which makes sense because of this negative exponent. Let's scoot this up a little. All right, so for this one, I'm going to take this 2, and I'm going to multiply it by the constant. Now, the constant that's out in front of this thing is 4/5. So I have 2 times 4/5. Then I'm going to write my x, decrease the exponent by 1, and then just don't forget to simplify. So I end up with 8/5 times x. All right, for this one, oh, sorry, I forgot to change, there we go. First thing I'm going to do is I'm going to rewrite this as 2 times x to the 1/2, so that when I go to take the derivative, and again, notice my notation, right? I'm very, very clear that I am taking the derivative. You take the exponent, multiply by the number out in front, which is going to be 2 times 1/2. Then you write x, lower or decrease that by 1, which makes negative 1/2. And then don't forget to simplify. So 2 times 1/2 is just 1. And this moves into the denominator. So I have 1 over x to the 1/2 or 1 over the square root of x. Okay, so for this next one, I'm going to write this as f of x equals 1/2, which is a constant, times x to the negative 2/3. And then I'm just going to apply the rules that I've been using all along, which is take this exponent, multiply it by the number that's out in front, so 1/2 times negative 2/3. Then you write your x and decrease it by 1. So that's negative 5/3. And then just, again, as always, don't forget to simplify. So that cancels with that. I end up with negative 1/3 x to the negative 5/3. And then, again, still cleaning this up just a little. I'm going to have 1 over this, actually negative 1 over. There's the 3 that's in the denominator, and this is also in the denominator. And it is the cube root of x to the 5th. Feel free to leave it that way. Okay, hopefully this one's not too bad. So let's see, the derivative. This exponent is a 1, so when I multiply by that, by what's out in front, the coefficient, right? You get negative 3/2. And then you write your x and you decrease the exponent by 1, but then all of this ends up being a 1, right? That's just 1. So the derivative is just -3/2. Okay, so on this one, I'm going to rewrite my original as 5/2 times x to the -3. And then I'm just going to apply that rule, which says take the exponent out in front, multiply it by the constant, and decrease the exponent by 1. Okay, and then again, simplify. So we end up with -15/2 x to the 4th. Okay, again, really important that you recognize that this is in the denominator. All right, so for this next one, I am going to simplify this denominator just a little bit. So let me rewrite it. So I've got f of x equals 5/8x to the 3rd, or in other words, 5/8 x to the -3. Now, when I go to take the derivative, I'll have -3 times 5/8 times x to the -4th, and simplifying and cleaning that up a little bit, I get -15/8x to the 4th. All right, this one, when I rewrite the original, okay, so when I rewrite this, I have 7/3, and then the x ends up being up here in the numerator with a positive exponent. And then hopefully the derivative's fairly okay. It's 2 times the constant out in front, and then the exponent decreased by 1. And when I clean that up, I have 14/3 x. Okay, so then next problem, f of x. Let me simplify it just a little bit first. So I have 7 times 3x squared, all in the numerator. Cleaning that up, again, this is even before I take the derivative. This is 9x squared, which is actually 63x squared. So now the derivative is 2 times 63 times x, or, again, cleaning it up one more time, 126x. All right, scooting it up a little bit. Okay, so now this is it's a function that is a sum. So I'm going to take the derivative in pieces, right? I'm going to do the derivative of this, and the derivative of this, and the derivative of this. So let's get going. So the first one, I'll have the 4 times -1/2, decrease your exponent by 1. Next one, 3 times 3, and then decrease the exponent by 1, minus, let's see, 1 times 2, and decreasing that exponent by 1. So then, cleaning this up, I have -2x cubed plus 9x squared minus 2. Okay, this one. All right, so this is the first time you're doing a trig function, but the derivative of sine is just cosine. So the constant out in front stays as a constant. The derivative of the sine is cosine, and you're done. All right, on this one, this is literally the same thing as 1/2 of sine x. In fact, let me rewrite it for you. F of x is equal to 1/2 sine x. So when you go to do the derivative, it's just going to be 1/2 times the cosine of x, or simplified, I would actually prefer the cosine of x over 2. All right, and then this last one, this is two separate functions, right? This is one function, this is a separate function. We're just going to take the derivative of them piece by piece. So the derivative of the first is 1x to the 0, and the derivative of cosine is negative sine of x. So simplifying, I get 1 minus the sine of x.